Hi everyone, Mrs. Luttrell here. Today's learning goal is to use the angle-angle similarity postulate. The angle-angle similarity postulate says, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This has two key math vocabulary words in it, the word congruent and the word similar. Congruent means the same. It means the exact same size. So when we're talking about angles, angles that are congruent are the same number of degrees. Similar means you're the same shape, but you might be different sizes. So in a triangle, it means that all the angles are the same, but one of the triangles might be smaller than the other triangle, or one might be bigger than the other triangle. So when it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. That means that if you have two angles that are the same size, they match, then the two triangles are similar. They're the same shape, but they might be different sizes. For example, if we look at these two triangles, they're different sizes, but they're the same shape. We know they're the same shape, we know they're similar because they have two angles that match. This angle here at B is 90 degrees, and this angle here at E is 90 degrees. So those two angles are the same size, which means they're congruent. We also know that these two angles match because they have a loop in both of them. They're both marked as a loop, which is one way in math of showing that two things are congruent. So I know that angle D is congruent to angle C. Since I have two angles that match, two angles that are congruent, B and E and C and D, I can use the angle-angle similarity postulate to say that these triangles are similar, which means that they're the same shape, they're just different sizes. So once I know that, I can write a similarity statement. I'm going to say triangle, and I can name my first triangle however I want, so I'm going to name it ABC, is similar, I use this little symbol to mean similar, to triangle, and now I have to be careful how I name it. I need my angles that match up to be listed in the same order in my similarity statement. So angle A here, you'll notice, has no symbols on it. It's unmarked. It needs to be in the same place that F is, because F is our unmarked angle in this triangle. So I'm going to say F. Then I say B, which in this triangle is my 90-degree angle. So it has to match up with E, since that's my 90-degree angle in this triangle. So E is second. And then I go to C, which is my angle marked with one loop. And it is congruent to D, my angle marked with one loop. So D has to be last, so it's in the same place as C. So my similarity statement says triangle ABC is similar to triangle FED. And again, I know that because they have two congruent angles, so I can use the angle-angle similarity postulate. Now there's a couple of other examples of the angle-angle similarity postulate where it's not quite as clear. So for example, in the second example here, you only have one angle in each triangle that's marked. And the triangles I'm talking about here are this larger triangle, this whole shape from V to W to Y, and then this smaller triangle that's inside it, this one ZXY. And if you look, we do have one set of congruent angles. So angle W here is 90 degrees, and it's congruent to this angle here, which is also 90 degrees. We don't have a second angle marked, but there is a second angle that we know is congruent, because if you look at this big triangle, one of its angles is this angle Y right here. And if you look at this smaller triangle, one of its angles is also this same angle Y. When they use that same angle, that angle isn't changing size. It's staying exactly the same, and they're both using it. So that angle is congruent to itself. So we can go ahead and mark it just to show this is the second angle we're using, and it's being used in both triangles. So now I can say these two angles are congruent since they're both 90 degrees, and this angle is congruent to itself. It's being used in both of the triangles. So there are two congruent angles, and I can use the angle-angle similarity postulate to say that the triangles are similar. To write my similarity statement, I'm going to name the big triangle WYV. So I'm going from my 90-degree angle to my marked angle to my unmarked angle. And I'm going to say that's congruent. So W was my 90-degree angle. Here my 90-degree angle is at X. So I'm going to have it be triangle X. And then I went from there to Y. So I'm going to go here from X to Y. So Y will be my second letter. And then I went to my unmarked angle V. So I'm going to go to my unmarked angle Z. And my similarity statement says triangle WYV is similar to triangle XYZ. Here's another example where you're only given that one of the angles in each triangle is congruent to another angle in the other triangle, but we can still prove that these two triangles are similar because there's another piece of information that we actually know. We know that this angle right here, this angle, I'm going to shade it in, and this angle right here are vertical angles. We know they're vertical because they're diagonal. They're across from each other in this triangle. They meet at a point, and we should know from previous chapters that vertical angles are the same size. They're congruent. So I'm going to go ahead and mark them. So I'm going to use two loops. This one here is congruent to this one here. So now, because we were able to mark that they're congruent since they're vertical angles, we now have two congruent angles in each triangle. This angle here, N, is congruent to this angle here, P, and then my vertical angles are congruent. So now I have two sets of congruent angles, so I can use my angle-angle similarity postulate to prove that the triangles are similar. When I write my similarity statement, I can say triangle, I'm going to go ahead and go N, M, O. So I'm going from single loop to unmarked to double loop, is similar to triangle. I have to go in the same order. So single loop here matches single loop here. So I'm starting with P. And then I'm going to unmarked, because here we have M, which is the unmarked angle. So here I'm going to Q, the unmarked angle. And then ending at O, my two loop angle. So I have that triangle NMO is similar to triangle PQO, again by the angle-angle similarity postulate. Now you might be wondering, when are triangles not similar? Triangles are not similar anytime that you don't have two angles that are congruent, or you can't make there be two angles that are congruent. So like in these two triangles, I know that these angles are congruent because they're both marked with a loop. I have no other information about any of the other angles. There's no vertical angles here. They don't share an angle. So these ones, I only have information about one set of angles, so these are not similar because there's no way to get information about the other angles. In these ones, right now I can't tell if they're similar. I know that there's a 90 degree here and a 90 degree here, so I have one set of congruent angles. I don't know this angle or this angle. So the first thing I should do is find out what those are. I know that all of the angles in a triangle add up to 180 degrees. Right now I have a 90 degree and a 20 degree. So 90 plus 20, right now I have 110 degrees. That means that this angle is going to be 180 minus 110. So this angle is going to be 70 degrees. I can use the same basic thing over here. I have an 80 degree and a 90 degree. So right now I have 80 plus 90 is 170 degrees. And I know all of the angles add up to 180. So 180 minus 170 is 10 degrees. So I have one triangle that's 90, 20, and 70, and I have one triangle that's 80, 90, and 10. There's only one set of angles that match. The other angles don't match. So since there's only one set of matching angles, these are also not similar. Please go ahead and try the homework. And if you have any questions, email me. Have a good day.